What? I'm in the same outfit as Monday? How did that happen? I just recorded at the same time and posted different times. It's fine. I'm a tricky trickster. All right, let's keep doing this. Okay, so it's Monday. We're back at it. We're ready to talk about space again. All right. First one, changes in the shadow. So crazy. Just like we have different seasons, did you know our shadows change as well? How crazy is that? So they're actually longer shadows in the winter and shorter shadows in the summer for us. If you're really close to the equator, basically you don't see it as much because your relationship to the sun is a little bit closer. Now, obviously, it flips depending where you are on Earth, but for us, longer shadows in the winter and shorter shadows in the summer. We are also going to do a shadow experiment in school. Well, we are going to rely on all of the classes working together because we have to take different shadow lengths every hour. And it's really hard to do because, sometimes you'll be in math and sometimes you'll be in writing. And I don't think they want me just busting in everyone's classes to make you take, lengths or measurements on things. So we'll go ahead and rely on our other classmates there to take down some quality data so we can compare the shadows. Pretty interesting. So, all right, fun fact for you. One of our standards, even. Right, the next one is constellations. And this one I'm sure you've heard of. Oh my goodness, I don't know if my head fits anywhere. There you go, right in the middle. So we have like different constellations up. I put some stars and we have the Big Dipper up here. And all constellations are different patterns that we see in the sky. Obviously, they're different planets or stars. They're usually named after animals or different characters or sometimes objects, like we can see over here. Um, and people used to really rely on them to navigate because they would say, oh, it's right here. You can also see the time of the year using constellations. So we're going to do a lot of work with that this unit as well. We have another interactive notebook that we'll go through that kind of shows us where we are and how that works with the different constellations. So it's crazy. Space is crazy. It's awesome. But, science in general, always something to blow your mind, right? Wouldn't be science without it. All right. Next, we're going to talk about stars. So we discussed stars a little bit in the last unit when we discussed how our star is our star, my personal star. I own the sun, by the way. So the sun basically seems so much brighter. So a lot of times I'll have kids, or even I used to think that clearly the sun is the biggest of all stars. It's the best of all stars. I'm still going to say it's probably the best because it keeps me warm and I am cold all the time. So thanks, sun. Appreciate it. But it's actually not, it's just kind of a medium star. Like it's just meh, it's pretty little. A star is just something that produces its own energy, obviously heat and light, which we just talked about. Weird. It's like I planned that or something. Crazy. Anyway, they go through lots of different stages and cycles. Different stars go through different cycles, but they all form from out of a nebula. And like I said, our star, even though we think it's like the best star, is really just kind of a medium star. It's the best medium star. All about it. This is a example of different star sizes. So as you can see, they come in all different sizes. It's pretty bananas. We are also going to be doing an activity with star sizes and they're basically where they are in relation to the Earth. They are light, some of them are light years away. And that's obviously why we can't see them like we see our sun. And so you can look for that this week on Friday. We are going to do a hands-on activity where we use different flashlights so you can see, yeah, this star is humongous and way bigger than our sun, but it's not as bright because look how close it is, or the difference in length. It's pretty crazy. I think you guys will really like it. So look out for that this Friday. Woohoo! All right. Oh, and by the way, you don't have to write any of that other stuff down because we're doing an interactive notebook. So don't write that. And if you did, I'm sorry, but it'll be good practice. It's fine either way. Anyway, We're going to talk about a nebula, and I believe this is our last. Nope, it's not our last one. I lied. All right. So nebula basically is a huge cloud of gases and dust. Gravity pulls the mass of the nebula closer together, and then the hydrogen atoms move closer together and they begin to collide. And as the temperatures rise, they actually start to become helium. Obviously, this process gives off a whole bunch of heat and light, more energy. See, connected. And then once that happens, a protostar is formed, which is like a baby star. It's probably not a baby star. Don't tell your other science teachers I said that. They'll probably not like it. It's the beginning star or a baby star. Okay, next is a black hole, and I am sure we have all heard of a black hole. Basically, it's an object that's so dense and it's like super powerful, nothing can escape from it, not even light. Light can do anything, not get out of a black hole. So if a star is really, really massive and has like huge mass, a lot of times they'll end their cycle, because we talked about how stars go through cycles and eventually die and all that stuff. It can end as a black hole. So, whew, that's bananas. All right. Last but not least is galaxy. It's a huge, distant collection of stars. We actually live in the Milky Way galaxy, the best galaxy, obviously. And so there are actually different galaxies in the universe, but they are very, very far from us. So I'll let you go ahead and worry about that number. Maybe I'll get Mrs. Diedrich to come read that for us. Or 25,000 light years from the sun. We'll do more work with light years when we are talking about the sun and the other stars, just to discuss what in the world a light year is and how we can even measure it. But yeah, so it's really far away. We're kind of, alone out here. It's kind of weird. All right, well, that's it for me. Hope this was a good brief introduction to what we're talking about in science, and hopefully those vocab words are a little bit easier to understand. We're going to get into some reading. We got a couple of computer activities, and then we got a few hands-on stuff to give you a better picture of what in the world is going on around us. It's kind of hard to picture when it's so big and it's so far away, so we'll use different scales to maybe make your brain understand a little bit better. But yeah. So you guys have a fantastic rest of your Monday, a marvelous Monday, if you will, and check back in on Tuesday. We got some reading to do. All right, kiddos. See you later. Bye.